Hello, we are a senior design team from the Biomedical Engineering Department at Michigan Tech. Our project, sponsored by Kohler Co, focuses on addressing the gap in knowledge about how wellness products such as Epsom salts affect bathtub materials. Currently, customers are incorporating these additives into their products, but warranties become voided due to unknown corrosion and buildup effects. Our goal was to develop a test bench system to investigate long-term effects that additives cause to Kohler jetted tub components, shower heads, and steam generators, and identify which components are most affected. Upon further investigation, we narrowed our scope down to Epsom salts and jetted tubs. To address this problem, we have established 4 primary objectives: simulate 3 years of product use, test all tub components, incorporate solid additives at varying concentrations, and establish a drying period between cycles. Our design process began with ideating and a brainstorming session with Kohler engineers. Using pairwise comparison and Pew charts, we decided to create a dual chamber system using 2 transfer pumps located under the tank to allow for a drying period between cycles. To validate our design, we first completed a small-scale prototype where we introduced Epsom salts to a similar chamber system with the sealant we were interested in testing. Before we could get our first test up and running, we had some safety hurdles we had to account for. To accommodate these, we added water leak sensors and did daily check-ins, added a UPS backup system, used cloud-backed 24/7 video footage, and used a variable aquatic heater. After all risks were accounted for, we began construction on our final prototype. The first design consists of 3 major components: the acrylic tank to house the jet and material testing components, the inline pump, pressure transducer, and flow meter, and the transfer pumps that move water between chambers after each cycle. These components work together to create a cohesive design that successfully simulates 3 years of daily product use with sufficient drying time between uses. We also suspended 3 samples per simulated year of fiberglass reinforced polymer in our tank to analyze the bulk material properties before and after salt exposure. Throughout the second semester, we conducted 2 life cycle tests. The first test was done with exaggerated salt concentration and the second with the recommended concentration. Here's what we found. There was a quicker and steeper drop in flow rate throughout the second simulation. This data shows a greater decrease in pump performance with higher concentration of Epsom salts. The increased concentration also correlates with higher average pressure, likely due to the higher fluid density and presence of gases in the line. Next, we completed material testing on the FRP samples. The FRP showed a more prominent stiffening effect for the higher concentration of salt in Simulation 1. The silicone sealant Dowsil 732 displayed a weakening in adhesive shear strength and ductility. The changes in both lap shear and tensile properties are likely due to the buildup of salts, weakening the bonds. Jonquier-Terpstra analysis identified significant differences in tensile modulus and ductility between simulated years under exaggerated conditions. Upon examining the sample color shift, Simulation 1 shows a larger shift in color, getting darker and more yellow with time. Through creating the test bench and the 2 simulations, we were able to determine how Epsom salts change in exposed materials' properties, a length of time for which products can be exposed to Epsom salts before a significant change occurs, and possible damage that was caused to the pump and jet during heavy use. Some future work related to our findings include improvements to our design, data collection, and possible revisions to Kohler's product warranties. Thank you to everyone who contributed to our success in this project, including our advisors, sponsor, department faculty, technicians, teaching assistants, and Kohler engineers.